This is lesson 2-8a, how to use x-intercepts to graph a polynomial function. We're going to have 5 main steps. Find the x-intercepts, determine if each one is a cut or a bowl, and I'll explain what that means. Determine the end behavior, plot a few points in between, and draw a smooth curve with arrows. Here we go, example 1. Graph y equals negative x plus 2 times x minus 1, the quantity squared. All right, step 1 is to find the x-intercepts. We're in intercept form already, so it'll be very easy. The x-intercepts occur at -2 and at +1. So right away what I'll do is I'll plot those on my coordinate axis. So -2 and +1. The next thing is to determine if each intercept represents a cut through or a bowl. And that's determined by the exponent associated with it, if it's even or odd. I'll just put an exponent here. Since this exponent is odd, it's kind of like y equals x and it's going to cut through. So this one right here is going to be a cut through, something like that. This exponent over here is even, so it's going to be a bowl, kind of like a parabola. All right, so this one would, now it could either bowl up or it could bowl down. The end behavior will help me determine which one is correct. All right, so I found the intercepts, cut, bowl. Let's do the end behavior. All right, if I were to multiply this out, I would find out it's just like y equals negative x cubed. I've got an x squared factor there and an x factor there and the negative. It's like y equals negative x cubed, which is like y equals negative x to the 1. It's negative and it's odd. That's what I need to know. That, I have an idea of what that looks like. That's a line like that. So my end behavior is going to be going up on the left side and down on the right side. And what I do is I just physically put that on my graph. So I'm going to be going upwards on the left side and downwards on the right side. I'm a visual person, that just helps me with the graph. Okay, so now I know that this is the correct bowling pattern, because if it's going to be going down here, it can't be bowling up forever, so it's going to be bowling down. So it's going to kind of do something like that, and to find a little bit more precision, I'll just plot a few points in between, at -1 and at 0. So I'll just make a quick table here. All right, so I'm just plugging -1 into the original function. So the opposite of -1 plus 2 times -1 minus 1 squared. I'll really do it quickly here. 0 plus 2 times 0 minus 1 squared. All right, -1 add 2 is 1. The opposite, -1. -1 minus 1 is -2. -2 squared is 4. So that's going to be a -4. Over here, 0 add 2 is 2. The opposite of that is -2. 0 minus 1 is -1. Squared is 1. That's going to be a -2. So I've got 2 additional points. -1 by -4. And 0 by -2. I don't need to worry about plotting points out of here. The end behavior will help me out there. Now I just put it all together as best I can. So going up forever, cutting through, going through those points. Bowling here. So if you want more precision, you can graph more points, but this is good enough for our purposes. Again, make your graph be smooth, put arrows on it. It's like a roller coaster. So once again, how to use x-intercepts to graph a polynomial function.